Okay, so today we're going to start going over the different types of chemical reactions. The first type of chemical reaction is a synthesis reaction, and this is also called a composition reaction, combination reaction, or addition reaction. So it has like 3 different names. So here, the analogy here is we have 2 people that are kind of unhappy because they don't have that special someone in their lives, and they get together and they start dating. So that's a synthesis reaction. So we're combining 2 or more substances to form a compound. And the thing to look for is only one product. Sometimes you'll have 2 different elements forming a compound between those elements, or you might have 2 compounds forming a larger compound. So to predict the product, we need to, if I were to ask you to predict the product, you would think about the typical cation or anion for the 2 different elements. In the product, you write the metal or the cation first, and you do the crisscross method to determine the product. So what I want to show you now is just a typical synthesis reaction between magnesium and oxygen. So I did show you guys this at the beginning of the year. So let me bring up that video. Okay, so what you're going to see in this video is the burning of magnesium ribbon. Now, this strip of metal that they're holding with the crucible tongs is a strip of magnesium ribbon, and we're going to be burning it with oxygen that's in the air, and we're going to use the heat from this flame to start the reaction. Now, if we were doing this in the classroom, I would tell you not to look at this directly because you're going to see it burns the very bright white light once it starts burning. So magnesium oftentimes is used in fireworks to create bright white lights you see in fireworks. So just watch. Okay, now they're going to do it one more time, but with a filter so you guys can look at it more directly. Okay, this substance afterwards is the magnesium oxide. Okay, so I want to go through a few different reactions, examples of synthesis reactions to show you how to predict the product. So let's say I ask you to predict the product for when aluminum reacts with oxygen. So we would write down aluminum. Remember, aluminum is not a diatomic, so we just write Al. It's also not an exception. Plus oxygen. Oxygen is a diatomic, so we would write O2. And then to figure out the product, we would have to think about the common charge for aluminum and the common charge for oxygen. So we know that aluminum's +3, oxygen's -2. We do the crisscross and we would get Al2O3. And then we would balance it. And again, I'm putting lines to make sure I'm just changing what's in front. I notice 2 and 3 both go into 6. So I would put a 2 here, a 3 here. Aluminum's not balanced, and I would put a 4 there. Okay, so that's a typical synthesis reaction. So when I ask you to predict the products, it will just be an ionic compound I'll ask you to predict the products for. And there I would expect you to be able to use your charges and write the formula. But you may be asked to recognize that a more complicated synthesis reaction is a synthesis reaction. In that case, just look for one single compound as a product. Okay, so now we're going to go over decomposition. So this will be the opposite of synthesis. So decomposition reactions are the opposite of synthesis, and they usually require energy. So here we have that couple that got together, and now they're not getting along so well, so they break up, and they're going to break up And when you have this type of reaction, you're either going to have a compound breaking apart into its elements or a compound breaking apart into smaller compounds. So the thing to look for would be only one reactant. Okay, so I'm going to bring up another demonstration to show you guys an example of a decomposition reaction. Okay, so we're going to watch the decomposition of ammonium dichromate, and there's the formula. Okay, so what they're going to do is they're going to heat this up, light it, so it starts decomposing. So what you can see is the decomposition is going to lead to some water vapor, nitrogen gas, and also a compound called chromium 3 oxide, which is Cr2O3. So there's our ammonium dichromate, and we're lighting it. And that it's actually kind of a dark green compound is the chromium 3 oxide that's being formed. We also see a lot of gases being formed, and that's why it's kind of like flying up like that and having that volcano effect. Okay, so here it goes a little faster, faster speed, and slower speed, so you guys can see what's going on. It's pretty cool. And faster speed again. Okay, so what I want to do now is I want to just show you if you were asked to predict the products for a decomposition reaction, what you would do. So here, let's say we had something like iron 3 oxide, and we were asked to predict the products for this reaction. So if I were to ask you to predict the products, I would just ask you to break it down into the elements that make up this compound. So we know that when iron is by itself, we would just write Fe. When oxygen is by itself, its diatomics, we would write O2. So that is how you would predict the products. Pretty easy.